In this video, I want to talk about divisibility rules. You could ask, why do we need to learn divisibility rules in a world where we have calculators? And that's a valid question. There's a couple of reasons. One is that divisibility rules, particularly for smaller numbers, can actually be much quicker than using a calculator. It can be quicker than pulling out your phone or pulling out your calculator. Another reason is that for very large numbers, numbers that are too large to fit in your calculator, with divisibility rules, we can still tell whether or not a number is divisible by certain other numbers. This will become important when we start working with irrational numbers and simplifying them. It will also become important to an extent as we work with fractions and other rational numbers. So you certainly don't, this is not vital information. You can still pass the class just fine without knowing your divisibility rules. But it will make it a little easier for you, and there will be a few problems where you're going to specifically be told, explain this using divisibility rules. So there are divisibility rules for many smaller numbers. We're only going to worry about the most common ones. The easiest one is the divisibility rule for 2. So we say a number divides another number if it goes into there evenly, and we write this with a vertical line. So this is read as 2 divides 10. 2 divides 10. This is not the same as 2 divided by 10, and it's not the same as 2/10. When one number divides another, we mean it goes in there evenly without any remainder. The divisibility rule for 2. A number is divisible by 2 if the number is even. So any even number is divisible by 2. Everyone knows that pretty quickly as they take math in high school and beyond. Or we could say if the number ends in the digits 0, 2, 4, 6, or 8. So there's 2. The divisibility rule of 3 is a little trickier, but here's an example. 3 divides 27. We could also say that 3 divides 120. I can say that 3 divides 300,060. In all of these cases, 3 divides these numbers, or they're divisible by 3. The rule for 3 is you add the digits in the number you are checking. If that is divisible by 3, then the entire number is. So here, 2 plus 7 equals 9, and we know 9 is divisible by 3. Here, 1 plus 2 plus 0 equals 3, and we know that 3 is divisible by 3. Here we have 3 plus a bunch of zeros plus a 6. We have 3 plus 6 equals 9, and again 9 is divisible by 3. So when we add the digits together, if those digits are divisible by 3, the entire number is divisible by 3. If they are not, the number is not divisible by 3. So if we had a very large number, let's say we had this. To determine if this is divisible, we could check, first let's check for divisibility by 2. We see that it ends in a 4. So yes, this number divisible by 2. Is it divisible by 3? Let's add. 4 plus 2 is 6. 6 plus 8 is 14. 14 plus 0 is 14. 14 plus 4 is 18. 18 plus 3 is 21. 21 plus 9 is 30. 30 plus 2 is 32. 32 plus 8 is 40. 40 plus 8 is 48. 48 plus 1 is 49. 49 plus 1 is 50. 50 plus 4 is 54. So can 3 divide 54? And you might say, well, I don't know. I only know my 3's up through 3 times 10 or 3 times 12. You still don't need a calculator. It still works. 5 plus 4 is 9. Does 3 divide 9? Yes. That means 3 divides 54, and that also means 3 happens to divide this number. This number is evenly divisible by 3. We can say that 3 divides it. So 3 is a little more tricky. You have to add the digits, and you would have to show that in your work. You'd have to show or explain that I added the digits together. My sum here was 54, and 54 is divisible by 3. We can also check for divisibility by 4. If 4 divides some number, we know that 4 divides 412. Why do we know that? The rule by 4 is we check the last 2 digits of the number. If 4 goes into those 2 digits evenly, it goes into the entire number evenly. So since 4 divides 12, 4 divides 412. We know that 4 divides 60, for example. So 4 would divide this number, 824,900,060. One thing that people sometimes are confused with 4 is, what if there are 2 zeros at the end? Yes, 4 divides into 0. You can't divide a number by 0, of course, but you can divide a 0 by any number. So 0 divided by 4 is 0. So 4 evenly divides 0, 0. Therefore, it divides 13,000. Remember, when we check for 4, we are always checking for 2 digits at the end. Not a single digit, but 2. And the last one we'll go over in this first video is another very easy one, 5. We know that 5 divides 9,270. Why do we know that? 5 divides a number if and only if a number ends with a 0 or a 5. So 9,270, let's check it using all of our rules so far. Does 2 divide it? Yes, because it ends in a 0. It's an even number. Does 3 divide it? Let's see. 9 plus 2 is 11. 11 plus 7 is 18. And 3 times 6 is 18. So 3 divides 9,270. Does 4 divide it? To do this, we will check and see, does 4 go into 70? And it does not. Let me show that to you here. 4 goes into 7 once, which is 4. And we have a remainder. So 4 does not. And just like we use this symbol for not equals to, we draw this diagonal slash through it. We do the same sort of thing here. This symbol means 4 does not divide 9,270. So in this video we learned divisibility rules for 2, 3, 4, and 5. In a follow-up video we will look at the rules for 6, 8, 9, 10, and 12.